Now that was a long section filled with twists and turns and pitfalls, and I intentionally kept all these mistakes in this video because I wanted you to see that whenever we're trying to do a penetration test or an ethical hack, it's not always straightforward. So I intentionally wanted to walk you through the thought process of how to scan a target, how to investigate certain ports and services, how to manually look a little bit further, how to find a vulnerability, exploit it, even though we fail sometimes, try again, try in different ways, try to configure the exploit properly, and so on. I could have very easily done this in a different way. I could have just shown you how the hack happens from beginning to end in a 2-minute video. But that would have definitely not given you the same benefit if I just handed you out the answer. This is why I wanted you to try this mission first, and I wanted you to try and maybe fail a few times before you succeed in getting access to the credit card database. And then I wanted to show you how I would have done that from beginning to the end, with all the mistakes and the pitfalls and the tries and the retries. And one of the reasons why I set up this mission for you is because I wanted you to revisit the post-exploitation slides. I told you that one thing that's quite unique about this course, and that makes it very different than other courses, is the fact that we do emphasize on post-exploitation, because as you already know by now, getting access to the target is not where the game ends. As a matter of fact, like I said, it's where everything begins. And there's a lot more to be done. So let's review together some of the post-exploitation slides because we might have just browsed over them throughout these videos. And I want to make sure that you actually imprint these in your memory so you can remember them whenever you're doing a proper ethical hacking engagement. One of the things that we talked about earlier in this course is the bash history. Now, you might have noticed that there was no bash history for the root user. There was a bash history though for the web dev user. And the web dev user's bash history was empty. A smart administrator will know how to keep the bash history empty, so in this particular scenario, the bash history wasn't very useful to us. Another thing that we mentioned is that after you compromise the host, more often than not, you will get non-root access. And then you're gonna have to find a local vulnerability or a local vulnerable software that you need to exploit to get escalated privileges. In this scenario, however, we got lucky. So we got our exploit configured and working properly, we fired it up, and then we got root access. But then again, the mission started when we got root access. Then we mentioned that towards the end of your mission, when you're completing the mission and when you want to get your data out of the target system, you will need to download files, and before that you might even need to upload files. And because in this case we were assuming that this is a massive file of millions and millions of credit card information, there is no way for us to just download it as is, so we had to use archiving and compression tools. Now, we didn't have to look a lot into the network configuration of the target, whether it uses any gateways or any DNS servers, because in this particular scenario, it's just one VM, one target that I've created for you. So that aspect we didn't cover because we already know what the answer is going to be. But nonetheless, this is still an important point to keep in mind when you're targeting a much bigger network. Then, of course, after we got access to the host, we checked what services are running locally on it. And that was our first cue, that there is a database service running that might be hosting the credit card information that we're after. Also, one of the first things that we did after we got root access is we made sure that we're able to log into the host or the target using SSH. Because that gave us assurance that we were able to still log back into our target without having to re-exploit it. Assuming that, for example, the administrators that are looking after this target, they end up patching the vulnerability in an hour or a day after we exploit it. There's no way for us to re-exploit it again. So what do? Now that we have access to the root user, we set up the SSH service in a way that allowed us to log back into the target whenever we wanted. Of course, we had also to investigate who we are when we broke into the system. And like I mentioned, we got lucky and we broke in as root. However, we did also explore who else was available on the system, what other users existed on the system. And we managed to find one other user, the web dev user, and that gave us yet another way to be able to re-log back into the system should we have lost our first shell access. And on top of that, we found out that the web dev user can use sudo on any program, effectively meaning that the web dev user could change into root or could behave as root. Now, of course, there's quite a few more post-exploitation techniques that we talked about that were not covered in this particular scenario because it's almost impossible to just jam everything in one target for you guys. So that would be a little bit tricky. Having said that, we did cover some of the most important post-exploitation techniques. So I hope that you guys understood everything we talked about. If not, as always, please revisit the videos, try the exercises manually. And if you still have any questions, we're available on the Hackers Academy forums. Just log in, post any questions you want, and you will get your answer in no time. Now, on to your mission. You didn't think you're going to finish this section without a mission, did you? When we got our first shell using Metasploit, so we set up the exploit, the struts exploit, we fired the exploit, and we got our shell. The first shell was a non-interactive shell. To get an interactive shell, what we had to do is use a Python command that gives us a reverse shell that we were catching on the Kali machine. So we had two shells. We had the Metasploit shell using the struts vulnerability, and from there we launched another shell that we caught using Netcat on our Kali. So we had two shells. Now what I'd like you to do is find a way to get an interactive shell without executing a reverse shell. In other words, when you fire up the exploit using Metasploit and when you get your non-interactive shell, find a way or find a command that you can run on the system that will change the non-interactive shell into an interactive shell without having to connect back to Kali. You can also use Python for that. The second part of the mission is you have to steal the SSH keys for the root user. Make sure that the SSH keys work, and if they do, that will give you yet another way to log back into the system without having to re-exploit it. And the last bit is find a way to download the credit card information using SSH and not using the web server or the Tomcat server on the target machine. Because if you think about it from a bad guy's perspective, you put all this effort and energy and time and money trying to break into your target. And then you get your hands onto the credit card information, you archive it in a file, and you host it on the target's web server, waiting for it to be downloaded by you. Now, this is a big file which is going to take hours, if not days, to download, because attackers, what they usually do is they would download these files bit by bit. They wouldn't download it in one go because a network administrator might notice a big spike in the network and that would tip them off that something fishy is happening. So a smart attacker would download these files bit by bit. So to leave these files on a web server, on a public web server while they're being downloaded is quite dangerous for the attacker because there's a chance that they might be discovered by somebody else. And all the effort, time, energy, and money put by the attackers, by the bad guys, would have gone to waste. Imagine if after all that, somebody else discovers the file and downloads all the credit card information as well. That makes the credit card information useless. So from a bad guy's perspective, it's smarter and better to use SSH to download these files. Because one, you're not hosting it publicly on a web server, and two, in our case, you're not hosting it publicly without encryption. SSH, on the other hand, is an encrypted protocol. So if for some reason the administrators are not investigating encrypted traffic on their network, which is quite common unfortunately, the files would have been downloaded without anybody being tipped off. So that was a lot of talking from me, just to say that the third part of your mission is to download the credit card information using SSH instead of HTTP. Once you're done with all that, we can move on to the next section.